coming to you live from a rooftop in Oakland, California above a micro-broadcasting facility in order to bring you important information. It's a special break, news break. We've entered your television frequency so that we can teach you how to construct and operate your own micro-powered radio station. With the assistance of myself, the Free Communications Commission, and Free Radio Berkeley, you'll be introduced to FM radio micro-broadcasting. Soon we'll connect you to Stephen Dunifer, who's a micro-powered broadcasting veteran. He's going to run through his workshop on building and operating a micro-powered radio station. You can buy kits for a micro-powered radio station through the mail from Free Radio Berkeley, which Stephen runs. And this video is going to show you how to build and operate those radio microstation kits. And if you don't have the kit, don't worry. You should still keep watching because you can still learn how it's done and learn a little bit about FM radio micro-broadcasting. The goal of this broadcast, obviously, is to teach you and all other individuals the information necessary to build and operate your own micro-radio broadcasting station. We thank you for your interest and wait for your participation because all citizens of conscience must demand that the no trespassing signs that have been placed on the airways by the federal government and the FCC be removed. We, the people who own the airways and who are entitled to the airways, must take them back by force, and this is the way to do it. So we now send you to Studio Zero, where your teacher Stephen Dunifer awaits.
Good yards, grounding equipment, and it's not something that's marginal to go on the air with. It's you can actually have a sound that's as good quality as most any commercial broadcast station. Even though the equipment looks simple, it does give you that capability of having something that's good quality and gives a good statement of how well this technology really works. Now, what's involved in this is pretty straightforward amount of equipment. People have this misconception of broadcast facilities. I mean, they can be as complex and occupy an entire building or complex of buildings, or they can occupy something as small as a closet in somebody's room. It just depends on the level of sophistication and the resources behind it. And of course, the resources behind what we're doing are rather small, so therefore the operations themselves in most cases will be a minimalist type of operation, but yet again still quite capable of acting as a full-fledged broadcast station. The basic elements that are involved in this process are, one, of course, a transmitter. Most people, again, have this conception of transmitters as these very huge pieces of equipment requiring all kinds of electrical power and various things to run. Well, that's not really the case. For example, in front of me, right here, this is actually a half-watt transmitter. This unit is quite capable of covering a distance anywhere from 1 to 4 miles, which is very adequate in most communities of a small size, a neighborhood, even a small town. A little transmitter like this could easily cover a small town area. They come in different sizes and shapes and power ratings. The power itself determines, in some respects, the area that's covered. The other determining factor is the height of the antenna and the efficiency of the antenna. Those are the two main things that will determine how far your signal goes. For example, this is another transmitter over here. These are all assembled from kits that we have. Slide it back here a little bit. What we have on top, this is actually the same half-watt transmitter, but it's being amplified by a 15-watt amplifier right here, below where all these little coils and things are. We have these boxes available so everything slides together and goes together in a very compact and reasonable manner. It's not really anything very big. You can see it's not 6 inches long, about 4 by 4 inches high and wide. So it's a really very compact type of unit when the lid's put on and everything. That's, these are your transmitters. This 15-watt unit can easily cover a distance up to maybe even 8 or 10 miles, depending on conditions and so forth. So those are the heart of the operation of the transmitters. And These units require a voltage. They need power to run. Now, they're designed to run off two sources of power. They can actually run from your regular wall current with a unit called a power supply, or they can run off actually a car battery. They're very adaptable for mobile use or situations in rural areas. You might have solar cells or battery array of some sort. You can power these off that quite nicely. But in most cases, you'll be using what I referred to as a power supply. This unit comes in various sizes of current capacity, but this one I have in my hands is quite adequate for the 15-watt unit and this unit as well. We have all these items available from Creator Berkeley. We're sort of, I guess, like a one-stop shop for this whole situation. But so you have a power supply, a transmitter. Well, what else you need? Well, another item, I've got two here, one in a closed box, one empty without a box. These are filter units. This is a larger filter in here for the higher power transmitters, and this is one of the lower power filter units right here. Just a couple of coils and some units called capacitors. What filters do is essentially remove harmonics from your broadcast signal. Every transmitter puts out harmonics. Now the problem is these harmonics can cause interference with other broadcast and communication services. And you don't want that, particularly because the first harmonic of FM transmitters ends up in the high VHF TV band, that is channel 7 and up. So we don't want to cause interference to those TV channels, and therefore we use these filters to cut out that harmonic from reaching people's TV sets. It's very important that a filter be used, because by doing that we deprive the FCC of one of its arguments about interference. So a filter needs to be used with every transmitter. The other issue the FCC has to deal with in this regards, one of their claims, is that these units are kind of amateurish and they tend to drift and cause problems. Well, looking in this unit, this is what we call a phase lock loop control transmitter. And what that means essentially is that we have a controlling circuit inside here that keeps this thing absolutely on frequency. And this frequency is programmed by these little switches on the board. They correspond, each switch setting corresponds to a different FM frequency. And we have a table of charts to allow it easy to set these. So what this means is this unit that we've designed is totally frequency stable. It's not going to drift. It's going to stay on the correct frequency that it's set for once everything's been tuned up and done accordingly to direction. It's always good to check the frequency every now and then, because there's always a little bit of aging in components. There's a way to fine adjust it. But for the most part, what we've done is we've tried to eliminate as much as possible here the technical objections the FCC has to this. They sort of see it in the earlier days when people might set up a little operation in a garage somewhere. The equipment might not be very good because people doing it didn't have a real idea of what correct broadcast engineering practice was all about. But we're trying to change that. We're trying to show that this can be done in a technically responsible manner that mitigates interference and other types of problems. So we've basically achieved that with what we're doing now. We have got transmitters that are stable, we have filters, and we have other means to keep these from being a problem to other broadcast and communication services. So we have our power supply, a transmitter, and filter. Well, what else do we need? Well, you've got to be able to hook these things up. to each other. So in radio work, there's a particular type of cabling. We call it coaxial cable. And it comes in different sizes and such, different capacities. This is a kind of a generic cable we have. It's general purpose, not very expensive cabling. So what happens is we have our transmitter, and this is the output from the transmitter. A short piece of cable with these type of ends. These are called PL259 connectors. The mating socket's called an SO239. So we would have a short jumper cable. We'll have maybe a foot or two of cable in there with plugs on both ends. This will plug, for example, into the output of the transmitter. Then this will plug to the input of the filter. Actually, either side is in or out. It's symmetrical, doesn't matter. And then you have a longer cable attached to this end. In some cases, you'll just have a shorter cable going to another item. This is called a power meter. A power meter is used for several different applications. One, in conjunction with an item called a dummy load, which again comes in various sizes and shapes depending on the amount of power it can hold or its capacity for dissipating. In the first case, when you're first building your transmitter, you don't want to radiate spurious signals all over the place. So by putting a dummy load on the output of the meter, that is the side it would normally go to the antenna, and a short cable to the transmitter itself, this allows you, by looking at the meter, to adjust your transmitter for the maximum power and set it up properly. So that's the first use of the meter. The second use is you might have it out here in line between the filter and the antenna. This would show you how much power is going out to the antenna. Also, a second needle on the dial shows you the amount of power coming back from the antenna. That's important because antennas have to be tuned properly to the right frequency. If you have too much reflected power, there's power coming back from the antenna because it's not tuned properly, it can actually cause damage to the transmitter. So having a meter is very, very important. And another meter I don't have on the table with me is called a frequency counter. This allows you to make sure that your frequency of the transmitter is set properly. It's just a small meter with little numbers on it, and it shows you the right frequency. If you're, say, at, for example, 88.1, and everything is set right, then the frequency counter itself will display 88.1. So you need those items. You need a frequency counter, you need a power meter. We have various types of power meters, some less expensive. This one, for instance, is about a $95 meter. We have ones about $35 as well, but not quite as accurate or as easy to use. So then we've gone from the filter to the power meter, and then we have a longer cable, such as this, or we have heavier cable. The problem with all coaxial cable is by the time you go from one end to the other end of the coax, your signal is going to lose some amount of strength or amplitude because it's just going to be attenuated due to the physical length of the cable. The longer the cable, the more the signal is cut back. So for situations that people can afford it, we have a lower loss, much thicker looking cable available that runs about $1 a foot or so. And you won't see that much loss over 50 to 100 feet by using that cable, whereas if you use this type of cable 50 to 100 feet, it may even cut the signal by half or more. So we have the cable, and then we go to dealing with how does the signal get out there. Well, the signal gets out there by by a unit called an antenna. Now what the antenna does is it radiates a signal outwards from the transmitter. It takes the signal coming up from the transmitter through the cable and puts your signal out to the real world. Now, an antenna is like a sort of like a tuning fork. When you hit it at the right frequency, it'll resonate and will tend to throw off the energy coming into it. Now there are all types of different antennas, and some are complicated and some aren't. What I have in front of me is the components that are necessary for creating what we call a dipole antenna. Now, what this is composed of, these rods fit into these clamps and are held inside the box, and then the cable is connected. One end of the cable connects on one rod, the other side of the cable, that is the ground side or the braid side, connects to the other one. Now, the way we set this up, it mounts in this fashion. Is the rods are in a vertical plane. And if you notice at the end here, we got a clamp, and we can actually adjust these to the right frequency. And that's a function of the wavelength. That is, at a broadcast frequency of 100 megahertz, your full wavelength is 3 meters. And these are a quarter wave, so at 100 megahertz, the length of this would be 3/4 of a meter, roughly about 30 inches or so. And these are fine-tuned with the meter. When you look at the meter, you adjust it for the lowest reflected power, and that's achieved by two means. One, when we're looking at this is the way they're set up in the box. The gap between the ends of the tubes will determine the amount of power reflected, and also the length. If it's tuned to the right length, it'll be a very low amount of reflected power. Now what happens is you determine the physical length according to the formula that we supply, and then you adjust to that accordingly. And then you have it set up inside the box. You look at your meter and you adjust the gap for the lowest reflected power. Once you've done that, you then adjust the ends one way or the other, either in or out, to get the reflected power even down lower. In most cases, if you calculate the right length, very little adjustment will be required other than adjusting the gap between the two elements of the antenna. So what we have really here is just a basic electrical outlet box with a couple of clamps. We have aluminum tubing, which we supply. It's a really simple antenna. There's really not a whole lot to it. And the other antenna designs are not much more complicated than that. For people that can afford it, we have a commercial antenna available, but it's not necessary. If you're on a budget, then you can start with something like this and work your way up. Antennas have certain characteristics, and the problem with this type of antenna is it tends to shoot the power more up in a sort of more vertical direction as well as a horizontal direction. So you actually have some power that's wasted. If you want to get as an efficient signal as possible, we have designs that can be built out of copper tubing, half-inch water pipe essentially. So if you have a friend who's a good plumber, handy with a soldering torch and a tubing cutter, you can make an antenna for $10 or $15 worth of copper plumbing materials, and we have all the diagrams available for that as well. That one I'm thinking about is called a it's called a Slim Jim antenna. It's kind of shaped like a narrow section, comes up like this, and then I can draw actually a picture of it. This one is particularly good if you use in urban areas. It sort of looks like that. It's not quite to scale, but these are your attachment points for the cable. Here, and these are adjusted up and down for the best match. All it really is, you've got four copper elbows here, here, and here, and this is a gap, and these links are all according to a formula we have on the diagram sheets. So I mean, this is something, again, you cut the copper tubing in the right links according to the cutting diagrams, lay it down flat, and solder it all together, and then you have an antenna. The problem with this is that once you cut it, it's set for to a frequency, and you can't adjust it like these. These are going to be adjusted to different frequencies. Once these have been cut, you're stuck on that frequency. But if you don't have to move the frequency for any reason, well, that shouldn't be a problem. What happens with this type of antenna, just to give an illustration of what I was talking about, if we take this as this kind of the plane of the antenna in this direction, the actual radiated signal is coming off at about a max of 12 degrees here. So it's really compressing it down in the horizontal plane. Same thing on the bottom, 12 degrees there as well. What this means is it's really going to concentrate the signal down. On a dipole antenna, your angle could be way up here like this, and that is just wasted energy. So what happens with this type of antenna versus a dipole, which is throwing energy every which way, is that the antenna will appear to have gain. In other words, that a dipole antenna will have what we call unity gain. In other words, 10 watts into the antenna will produce 10 watts out of the antenna. However, into this Slim Jim antenna, which is diagrammed here, it'll actually have a gain of 2 or 3. In other words, 10 watts in will actually have the equivalent power of 20 or 30 watts out. It's called effective radiated power. So an antenna can actually increase the efficiency of your transmitter because it's compressing the signal down into the horizontal plane more and giving it more punch. And this is particularly good for urban areas where there's a lot of clutter and stuff around, where you just want to go, like you're on maybe a 3 or 4 or 5 story building. This is a really good antenna to use. When any antenna is used, you need to mount an antenna above the roof. Say this is your roof like this. You need to get as high up on the roof as possible. We have used mostly standard TV antenna masting. So you could go up like a 10-foot mast and a little holder of some sort. Or you can use a tripod mount and use what we call a push-up mast with guy wires, so you can go up, like this, for example, with your antenna up here. Again, those things aren't very expensive and can be gotten in most TV radio supply stores without a whole lot of problem. The other thing, such as antennas, is this: they need to be insulated from the masting. So, for example, like with a Slim Jim, you might have a piece of plastic pipe and it's clamped along the side to brace it, and then this is clamped to your mast, for example. These are all things that we cover in our documentation, but generally speaking, you really have to decide what your situation is and select the antenna that's appropriate for it. And again, you want to keep the distance between the transmitter filter and the antenna as short as possible. So in many cases, and it's also a good idea, what we do is we'll separate, for example, say this is your transmitter. You might want to, say in your house or somewhere, you actually might want to put the studio, where the audio equipment is, some distance from the transmitter. Because what happens is the transmitters will radiate energy which will be reflected back into a mixer, for example, and that can cause some problems, most notably hum and other objectionable noises. So most of the equipment we use has RCA type inputs, which are high impedance. Now, to get around that problem, we use matching transformers, or standard microphone matching, high to low impedance. They get them most any place. They have a high output here, a low here. They have standard microphone connectors, so you could even use standard microphone cables. So we use that with an adapter to adapt a quarter inch jack to an RCA, standard cabling you can get. And then we run on this side a 3-pin XLR male connector. That comes down and goes to the same arrangement on the other end. And the 3-pin XLR here in low. So you just use an adapter which converts this quarter-inch phono to the RCA. This length of cable can be anywhere from 25 to 100 feet or even more. It has to be three-wire shielded cable, which is standard audio stuff, nothing esoteric. So that way you can put your studio somewhere else in a lower floor of a house or basement, whatever, run the audio feed up to the transmitter. Now, that way then you would have your cable going on up to the antenna and maybe make it 25, 50 feet of cable or something like that. Now, while we're talking about audio equipment in studio, there are certain things to keep in mind when setting things up. One is grounding. You want a good ground. It's also helpful to take a grounding stake, a big copper rod. You get an any sort of hardware store that has electrical supplies, and drive that into the ground outside the studio and make a common ground for everything. It's reference to that ground. It'll eliminate a lot of noise and problems. The other thing which you have to have between the RCA output and the transmitter, that is the output mostly, in this case, coming from the studio equipment, the last item in the chain is that is an audio chain, is a limiter compressor. Now what this does is that it keeps your audio signal at a predetermined level and does not allow it to exceed that level. Now why is that important? Well, that's important because the amount of audio signal going into the transmitter determines how wide your signal spreads. In other words, we have a situation in the FM band where, let's say, you're at 88.5, all right? And this is frequencies up and down and below, and this is 88.7. The FM frequency channels are separated by 200,000 or 200 kilohertz. So what this means is that the distance between here is 200,000 cycles. You're allowed a maximum deviation either side of 150,000 or 150 kilohertz, or otherwise known as plus or minus 75 kilohertz deviation. What will happen is if you over-modulate the transmitter, the signal will start spreading this direction, and it'll start distorting and creating all kinds of spurious signals. We call them spurs. And you don't want that to occur because, again, we're trying to deprive the SCC of every technical objection they have. Because what the circuitry does, it responds to the audio signal and produces this deviation, and we don't want to over-modulate or over-deviate the signal. So therefore, we don't want the input signal to exceed a certain threshold where we determine, the modulation. Unfortunately, we don't have expensive modulation monitors. So what we do is listen to the signal and determine the audio amplitude of the signal by listening and comparing it to other stations. Because other stations are using a lot of audio processing, their signal will actually appear louder than it actually is. So you want your signal a little bit under that of other stations. And a limiter allows you to set the signal so it will not exceed a predetermined level. So therefore, a limiter is very important to use, because you'll end up with like say a soundtrack, or somebody gets excited and their voice really goes up, and it'll cause the level to increase, and if you're not doing something to keep it from exceeding a certain threshold, it'll over-modulate the transmitter and cause problems. So that's very important. We do have several different types of limiters available, and are looking to try to expand that line so they aren't too expensive. Unfortunately, they tend to be a little on the expensive side, in the $100 to $200 range. We're looking to try to develop a less expensive one for people on a budget. Now, in talking about your studio setup, all the things that you have in a studio setup are basically items that can be found in most home stereo configurations and such. You can go to garage sales and get CD players, tape players, whatever of that nature. Or you may have a lot of stuff sitting around, again, donated, whatever. Now, part of this is the control unit is known as a mixer. This allows you to switch between your different audio sources. This is a very simple little mixer, which we don't really use much of. This is brought in. But it gives you an idea. This one has things for tape and phono inputs and one microphone. We basically use a mixer style. It's called a disco style mixer. You can get these at various stereo stores and such. We do have a variety available as well. And these will cost anywhere from $150 on up for a mixer. Perhaps you can find somebody who is doing the disco scene and no longer is using their equipment. You might be able to buy a whole setup, including turntables and mixer, for a reasonably good amount of money. But no matter, the mixer is an essential item because, one, it has meters on it to allow you to see what your indication is. Now, if you just want to do something fairly simple where you do a broadcast just for a couple hours a night, you could just do up a tape and do the levels and set them accordingly and run it that way if you wanted to. But it depends on your budget and what you really want to do. At Free Radio Berkeley, we're on 24 hours a day, 7 days a week, so we require a little more sophisticated setup. But this is one of your basics, is a mixer. And I was saying that, again, your equipment, you may have a couple of CD players, a couple of tape units. The dual type of cassette units work real well because they allow you to queue up a tape at the same time one's playing and so forth. But that be as it may, you can essentially build up your audio equipment as you go. No matter what, you can still put a station on the air for $1,000 or less, sometimes even under, depending on what you're looking at. The equipment itself, exclusive audio equipment in terms of transmitter, will run anywhere from about $250 to $500. That is, if you build it yourself. At this time, we cannot provide assembled equipment, that is, transmitters for use within the United States, due to the fact our equipment designs are not FCC type accepted. So you'll have to find someone who has the requisite technical skills to build up the transmitters themselves and the amplifiers. Now, to give you an idea of what's involved in this process, what I'm going to do is show you what goes into it. These are units which we built up. When you order a kit from us, you'll get this rather unpretentious looking envelope. After struggling with the staples and all, to keep little parts from migrating, little parts have a tendency to do. And you'll open it up. And you'll say, oh my goodness, what is all this? And fortunately, I didn't have a little tray here to dump stuff into, so you shouldn't really do what I'm doing, but I'm going to try to catch everything so it doesn't go skittering everywhere. Now, what we supply are diagrams that you'll see on the, as a part of the video production. These will be brought up on the screen. I don't have them in front of me right now, but they'll be part of the production, so you'll see that intercut to as I'm working. And because I know where stuff goes, and I have also a board in front of me, doesn't really pose any particular problem. I think I got these board layouts just about memorized anyway, having designed them. Now what, you're kind of looking going, oh my God, these little small parts. Well, again, we have the diagrams and circuit layouts that'll help you identify what all these little parts are. What we start with is a circuit board, and this provides two purposes. One, it's something for everything to be mounted onto this to support the components, and it also provides all these circuit interconnections between the different components that essentially create a functioning unit. Now, you require some basic tools in this endeavor. The first is a soldering iron. It's a very important item. Without a soldering iron, you won't be able to put these together. Now, soldering irons come in various sizes, shapes, and power ratings. We don't recommend anything using more than a 25 or 30 watt soldering iron. We also recommend that you use a good quality iron as possible. If you're just doing a one-time thing, then maybe a small, cheaper iron, kind of throwaway thing is okay. But the main thing is you want to have a really small tip on it. You don't want a big tip, because that'll cause problems when you're trying to put the unit together, because as you can see on the circuit board, some of these pads and what we call traces, that is, interconnections between the parts, are kind of tightly spaced. So you should have a good steady hand with this. And Then a couple of other items that will require some basic hand tools. And a sponge. A sponge helps keep your tip clean on the soldering iron. It's important because you end up with residue built up. Inside the solder is actually resin. There's a resin core inside here that helps ensure a good connection between the metal surfaces that are being soldered together. Basic tools. One's a thing called needle nose pliers. Again, you can pick these up at various stores and such. These are good for picking up parts, shaping leads, and such. Another thing for helpful, like holding things, is a pair of hemostats. Again, these can be gotten in various places. And then we have a couple of different type of cutters. These are called diagonal cutters, and these are called a flush cutter. It allows you to get down really close and cut. Good for trimming leads and such. So what I'm going to do is illustrate a little bit of how one of these goes together. This little item right here I'm adjusting is called a third hand, and it helps when you're putting things together. Just kind of clip it in there like that. Now, to sort of give an idea of sort of parts identification, you may be dealing with we supply the necessary wire and cable in the units. This is, again, a type of coaxial cable. It's a smaller cable. You don't need a very high-capacity cable to just take a half a watt out of this unit. So we have just a small bit of coaxial cable to allow you to connect from the circuit board to the output connector. As I said before, this is an SO239 connector, so we call it an RF connector. They're a common type thing. You see them on CB and amateur radio equipment all the time. There are more expensive type of connectors, but we prefer using these. They're simpler for people to deal with. Now, you have various, you can see they're very small components out here. These things in the wrapped up are called integrated circuits. They're part of the transmitter itself, part of the control circuitry and such. Then we have connectors. These connect your power to the box through these type of connectors out here. These are called banana jacks, and these are banana plugs. These are also the same mating sockets, the banana sockets they go to. Then we have an RCA connector. This again mounts on the other side of the chassis, in this case, where your audio feed comes in. This is standard audio type of connector. This item is called a potentiometer, a variable resistor. In the slang of the electronics industry, it's called a pot. Don't smoke it. That's also in the term for burning up a circuit. It's called smoking it. And this item, it's got three little legs on it and markings. This is the output transistor. Transistors, again, come in different sizes, shapes, and such. For example, we'll put this in here. Yes, here we go. This, again, a little item, a little black item here is another transistor. This is part of the circuit as well. So those will be different things to look at. Then we have other components. For instance, this is called a voltage regulator. It regulates the voltage on the circuit board, takes the voltage coming in and keeps it at a steady, constant voltage, in this case 12 volts. Then ones that kind of are particularly confusing for people are called resistors. Since these are so small, you can't have the code stamped on it like a transistor or something. So instead, they're color stripes on these, and the colors themselves designate a certain value depending on the combination of colors. And we have on all the parts list the color bands. These are like little bands of color on here. We have the color bands called out so you can identify each component, each resistor. And other items, and these come in different, again, shapes, sizes, varieties, are capacitors. In many cases, the markings will be on the side of it. This one in my right hand is an electrolytic capacitor. It has polarity. One side has to be put on ground. As the negative side goes to ground, if you reverse it in the circuit, it can cause problems. This one is what we call a non-polarized capacitor. It doesn't matter which way you put it in, because it doesn't have polarity. Again, we describe these on the parts list fairly accurately so you know which one is which. These two little green items, these are actually variable capacitors. They have a little tuning tool that goes inside, and they can be adjusted so their actual value can be changed over a particular range. And these are the same thing, variable capacitors. Again, these are just have a different range. They're actually color-coded. The color coding tells you the range. That's noted accordingly on the parts list. And let's see what else. This little thing in a silvery can, this is called a crystal. This provides a reference frequency for the control circuitry, so it knows how to control the frequency properly. And then we have a thing called inductors or coils. These create a certain amount of inductance in a tuned circuit, and these come in various sizes, shapes, number of turns. The number of turns and the diameter and the size of the wire all determine its value in the circuit. And some more mechanical type items. This is called a heat sink. This slips on top of the transistor and helps dissipate heat. You put it on by squeezing it outwards like this and slipping it over the cap part of the transistor, so it slides in tight, goes in there like that. I won't push it all the way in because I need to, but that helps move heat away from the transistor. You don't want the transistor to overheat, and that helps cool it. This is another tuning coil, little yellow guy here. It's tuned by putting a little screwdriver into the top and turning one way or the other. This is called a radio frequency choke. Acts as a filter essentially to the circuit. It presents a certain amount of resistance to radio frequency energy, and it's used to isolate parts of the circuit from each other. So this is what they look like. There's several in the kit. And then we have some other hardware items. These are just little bolts. It's called 440. That's actually the designation of the size. It's called 440. And they come in various lengths. There's threads and all that on. These little tiny machine bolts, basically. This little item right here is a spacer. This goes underneath the board and keeps it a certain distance above. There's like 4 in each corner, so it mounts it above the chassis so the connections don't short against the underneath section. And then you have little lugs. These are called grounding lugs. These actually mount on the chassis right where the connector is, so that you have a nice ground connection when your cable is connecting to the output connector. The inner conductor, when this outer conductor stuff is stripped off and peeled back, you have interconductor, which is soldered to here. The outer braid shield is then soldered to this. So it provides a nice convenient way of connecting the cable to the connector. And what else we got? Little tiny guy right here, barely see probably. This is a ferrite bead. These go over the ends of a couple of the resistors in a circuit. It's kind of slip on, it's not probably the right one, but that's how it would go in the circuit. Leads bent over, and then this is put onto a certain section of the board. This helps provide stability to that part of the circuit. This is an RF design technique that is used to keep the circuit as stable as possible. And there's a couple of those in the kit. There should be, hopefully. They tend to get lost really easily. Pretty much the other remaining components, these are called inductors. They're like a coil. They're wrapped around a little core inside. These will also help isolate sections of the circuit from each other to keep RF circuitry clean in different sections. So you have those. And what else we got? This little device right here is called a variable capacitance diode. This is actually the heart of the FM circuit. The area that this operates in is actually the area that produces the FM signal. And when this diode is called a variable capacitance diode, it acts actually like one of these capacitors. In other words, I can tune this one mechanically with a little screwdriver tool, but this variable capacitance diode can be electronically tuned with electrical voltage. And this is what produces your FM signal. When this is hit with an audio signal, it actually will cause the value to shift by a certain amount. And when it shifts, that produces your frequency modulation. So this is actually the item that produces the FM signal is responsible for it. So it's rather important. And otherwise, the rest are pretty much the same parts. These again are capacitors. There's various configurations. So with this configuration in front of me, what I do is kind of show you the basically a little techniques on this. I'll put a few components in the board. Angle it there so now I can get a view of it. Bring this around so I have a little. Okay. I'll start with an easy one. Big item. Put the coil in. Again, you'd be looking at a diagram we would supply with the board. And you'll be seeing that on your screen. The other little tool that we use is called a component lead bender. This allows you to bend the leads in a uniform manner with a certain amount of distance between them. In the resistors, we use 4/10 of an inch spacing. So you get a uniform bend like this. And you just insert it in the board, like so. What you want to do when you're doing this is every time you insert a part, you'll have a parts list, which will be up there in front of you on the screen, and check off each part. I'm not doing it right now because I've done this so many times I can probably do it in my sleep, but it's a good idea to confirm each part you're putting in, make sure you got the right values as you go along. You should work, don't be in a hurry, and just work slowly and take your time about it. And as long as you can follow a diagram or have a friend help you, it really shouldn't be a problem. We can take people who've never really done this before. I mean, this is what a company which doesn't exist in its prior form, called Heathkit. They would take people and set them down and have them put these things together. They give them instructions, and if they couldn't figure it out, they go back and change the instructions so the average person could do it. So the company was producing everything from small little radio kits all the way up to color TV sets people could buy as a kit. But they went out of the kit business some years ago, which I consider to be kind of distressing, because everyone now is in such a consumer mentality of, oh well, I'll buy it now and throw it away tomorrow, and not even worry about how they'll fix it or anything, which is kind of unfortunate that we have that kind of mentality that doesn't encourage any sort of hands-on experience and such, because really what we're all about is empowering people, not only empowering them in terms of the radio work, but generally trying to empower them in other aspects of their lives. That is, being able to take, for example, something like this kit I'm working on now and build it. And that gives you a certain sense that, hey, I really built this, and I really, did something with this. I did something with my hands. I put something together and made it really work, and I now have an understanding of how things go together in this type of area. And it's called a component lead bender. This allows you to bend the leads in a uniform manner with a certain amount of distance between them. In the resistors, we use 4/10 of an inch spacing. So you get a uniform bend like this. And you just insert it in the board, like so. What you want to do when you're doing this is every time you insert a part, you'll have a parts list, which will be up there in front of you on the screen, and check off each part. I'm not doing it right now because I've done this so many times I can probably do it in my sleep, but it's a good idea to confirm each part you're putting in, make sure you got the right values as you go along. You should work, don't be in a hurry, and just work slowly and take your time about it. And as long as you can follow a diagram or have a friend help you, it really shouldn't be a problem. We can take people who've never really done this before. I mean, this is what a company which doesn't exist in its prior form, called Heathkit. They would take people and set them down and have them put these things together. They give them instructions, and if they couldn't figure it out, they go back and change the instructions so the average person could do it. So the company was producing everything from small little radio kits all the way up to color TV sets people could buy as a kit. But they went out of the kit business some years ago, which I consider to be kind of distressing, because everyone now is in such a consumer mentality of, oh well, I'll buy it now and throw it away tomorrow, and not even worry about how they'll fix it or anything, which is kind of unfortunate that we have that kind of mentality that doesn't encourage any sort of hands-on experience and such, because really what we're all about is empowering people, not only empowering them in terms of the radio work, but generally trying to empower them in other aspects of their lives. That is, being able to take, for example, something like this kit I'm working on now and build it. And that gives you a certain sense that, hey, I really built this, and I really did something with this. I did something with my hands. I put something together and made it really work, and I now have an understanding of how things go together in this type of area. And sometimes if you don't get something on the air, just the fact that you've been able to successfully complete and put something together is as much of an empowerment type of experience as anything else. So we really try to encourage this more of a hands-on, do-it-yourself type of ethos. So I put the coil in there like that. Let's put a few more things in and show you the proper soldering techniques. fluorescence diode. I'll put a couple of transistors in. You really haven't worked with soldering iron. If you have a friend who's done it, it's not a hard thing to learn. We, as I said, be able to teach people in 10 or 15 minutes how to use a soldering iron and achieve a really good solder joint. Again, it's a matter of being, taking the patience to do it properly, and also when you put your parts out, you should sort them out, in other words, by part and by value. It'll help you when you assemble. I haven't done it here, but it just helps if you sort everything out and do that. Well, I've got enough on here at least to play with. Now what will happen is that sometimes the parts will have a tendency to fall out a little bit, so sometimes you have to bend the leads a little on the bottom, so you just kind of push them over to one side, pull them down. The resistors seem to be like this. Just tweak them out a little bit like this. No. Ensure they stay in there. And now what we're going to try to do is demonstrate a little proper soldering technique. Now the solder you want to use is what we call resin core solder. Some people have tried to use plumbing solder type stuff, and that will not work. In fact, it'll damage and will not work. And the idea is that first you want to do, if you haven't done it already, we have a process called tinning. What this does is it gets a nice shiny coating of solder, which coats the end of your soldering iron tip, and just get out the excess. Now, don't really do things for this angle, but usually. But what you want to do is you hold your soldering iron at about a 45-degree angle to it. You don't want to put the solder directly on the iron tip, but on the other side of the lead and the pad, and then just pull the iron up, draw it up like this. What you want to do is form for example, this is the component lead. We'll make a big magnified thing here. And this is the board. What you want to do is create a little thing like this. It creates a little well, like a little mound of solder comes up around the edges of the lead and circular, like a little, well, I guess the easiest description, like a chocolate kiss type thing. It looks like a little thing in the center. And then the lead will be cut here later. But the idea is you want a nice, shiny connection without much solder. You see, I don't have very much solder on here because too much solder is not good. And you want it perfectly shiny, because if you don't heat it up enough, what will happen is it'll form what we call a cold solder joint. That is, it will not be mechanically stable. And if you rattle the board around, it might make connection when you test it, but if you move it or flex the board in some manner, then the joint itself might break and it will act erratically. That is the cause of many a problem. People will try to figure out why something doesn't work. They'll go round and around and around. In most cases, unless it's something like a defective component, it'll be a bad solder joint. Bad solder joints have caused more problems than virtually any other type of error in constructing a kit. So again, we'll just kind of go through it here. We put our iron about 45 degrees, let the wire lead and the pad heat up. Bring it up like that. Make another joint. And it would work our way down. Another one. Okay. As you work, you can trim the leads as you go to make it easier to get to things. Again, just want to work carefully and slowly and just make sure every joint looks good. Now when you get to soldering in these little sockets to hold the integrated circuits, they have a tendency to really slip out a lot. So what you want to do is solder just one corner of those. Just a little bit of solder is all you need. Like that. And then look on the then holding the board from the other side, see if it's in there all the way, and just heat just a little bit and push, make sure it's seated all the way down. In this case it is. And then you can do the opposite corner. Like that. So then look at it and it's all the way down. Then proceed to solder the other pins. Again, it's very tightly spaced. If you want very much solder, just heat it up. A little bit of solder. That's all I need there. And then you want to proceed to the other components here. We have the little variable capacitor down here. It really shouldn't, if you get everything sorted out, it really shouldn't take more than a couple hours to assemble one. Things are moving on me, the problem here. Just an idea. Usually I don't work over it in this way. So you can see on the camera. Now these larger areas of the board where it takes a little longer to heat up because you've got a lot more surface, so you just make sure you get a really good connection there. And when you solder the transistors, you want to be real quick about it. You don't want to overheat them. That can damage them. So you want to be, in fact, if you're not too sure yourself, you'll take like a pair of hemostats or some tweezers or something and clip it on the leads on the other side of the board. The lead you're soldering. That'll act to draw away heat from the transistor itself. And of course, the thicker the lead, for instance, in this coil, it's got a little bit thicker wire, and it, of course, takes a little bit longer to heat, so you have to have a little patience in that respect. So that'll give you an idea. Generally, because we're just sort of doing this for illustrative purposes, it's best to like go through and put all the resistors in first and solder them, and then capacitors and various other components working your way through the list. You can just start at the top of the parts list, which is grouped according component, and work your way down. That might be the most logical thing to do. One was inclined to work in that manner. And again, we're just trimming leads down. You notice this little red wire here. This is this coil. But when you solder it in the board, you actually need to take a little knife or a little bit of something and scrape these leads, because they have an enamel type coating on them. We have to scrape it off so it'll solder in properly. We had people try to solder this with a coating on it. It doesn't work very well if you're getting a connection. So that's one thing to keep in mind when you put these kits together. So then we have unit soldered here, and it's basically how it'll start looking to you. Once you'll fill it out, and it'll eventually look like this unit right here. So that's really what's involved in putting at least the assembly aspect of it together. Of course, you need to, and we supply the boxes, the enclosures, drilled for the voltage input jacks, the output, the input level control, the audio input itself. This controls the level of audio signal going in to allow you to adjust it the proper level. So anyway, so you don't have to worry about doing much in the way of having to drill or fabricate the enclosures. We do that for you, so you can buy the kit, the enclosure, everything you need has already been done in that manner. All you have to do is just be careful about your assembly and hooking everything up properly inside and making the right connections and so forth. That's really really the heart of the matter. And if you do have, again, it's helpful if you have some basic mechanical skills and have some familiarity with this, or at least have someone that can work alongside you if you don't. In that respect, we hope to be able to provide people with technical mentors across the country, people who do have skill in this area and who have built equipment, who put broadcast operations in the air, people who assembled our kits, whatever. So we're going to be organizing that as we go along. This is quite an undertaking for just a small group of us, and we're trying to do this as well as we can, given the circumstances, limitations of our own resources, of personnel, and so forth. Putting together these kits, a lot of the fabrication work, it's all being done by volunteers right now. So there are sometimes delays in what we get out and so forth. People just have to realize that we're not a Sears and Roebuck type operation. We run on volunteer help, and we do the best we can under the circumstances. So if people do have skills out there who are watching this, we would love to hear from you, so you can help other people get on the air and stay on the air in a reasonable fashion and observe good broadcast engineering practice. So really what we're looking at is a really simple, comparatively speaking, compared to computer circuitry and such type of operation. This is not anywhere near as complicated as the circuitry you might find on a computer circuit board or other consumer electronic gear for that matter. So we feel that the assembly of these type of operations is well within the capabilities of most people if they approach it with the right attitude and a little bit of help from a friend or whatever in the process. And I feel that we can, through this endeavor, really create kind of a situation of a real true democracy in this country, that everyone to have their own voice. We consider this sort of leaflet of the 90s, these little transmitters. You can spend a lot more in cost in printing an 8-page tabloid newspaper than you would building a transmitter, and reach a lot more people, because people may just pick up a flyer or whatever and look at it and throw it away. And with a radio station, people will listen to it, hopefully, if you're doing good programming, something reflective of the community, that you have as much community involvement as possible, then it becomes a valuable resource. And also, it's a lot easier on the trees. You don't have to worry about chopping more trees down for more flyers. And we've seen with Free at Berkeley that to be an effective means that we've been able to objectively see that more people are coming to different events and activities as a result of these being put out and promoted on Free at Berkeley events and things that don't get a whole lot of play or promotion on other broadcast stations, particularly things dealing with community issues that don't seem to get much attention, if any. So what we've done within this process is to show you some of the basics, what you'll be working with. We hope to, in the very near future, have a complete book available on this, going from step A to step Z, on how to put your own station on the air. But what we're attempting to do within this videotape is show, all the basic equipment, what you need to do to get on the air, what is involved in putting a kit together, some basic aspects of soldering a board, assembling the transmitter, of testing it, and so forth. So I hope that this will encourage you to consider putting your own community voice on the air, and join many other people across the country who are doing this right now. We have many voices on the air, small stations in Northern California that are on a couple of days a week. In Arcata, there's in Santa Cruz a station on 24 hours a day, Free Radio Santa Cruz. In San Francisco, there's Radio Libre. In San Francisco as well as San Francisco Liberation Radio. We have expecting another 1 or 2 stations to go on the air in Berkeley. And further south in Salinas and Watsonville, there's stations on there, primarily Latino, La Raza, Mexicano, Mexican field worker stations, representing the voices of farm workers and many people on the very lowest end of things who no other way would they ever have a voice except through this technology that we're trying to get into many hands as possible. Further even to the south, down the coast, there's a station called Excellent Radio. They're a 6-watt voice in the community there, offering a diverse range of community expression and opinion. They've become a very valued entity within that community already within the last 6 months or so of their operation. We have stations all across the country, other than California. We have reports coming in almost every day of people being on the air. So we really invite you to join this growing community of micropower broadcasters through this relatively easy-to-use technology. I mean, once you've built these units, we found that as long as they're constructed properly, you don't have to worry about them. They stay on the air. We've had same transmitters running for over a year without any fixing, maintenance, or repair required. So it's something you can, once you've got it built, it's there to be used. And we hope that that's something that you'll do. And to touch a little bit more on the legal aspects of this, as we said, this is something you have to think about seriously because there are legal consequences involved if you decide to do this. And we do have legal help available. We do have attorneys working through the National Lawyers Guild, Committee on Democratic Communications. I'm a member of the National Lawyers Guild myself as a legal worker, and we have attempted to create a body of expertise to aid in this legal fight. And we have briefing papers, documents, various things available. These are available on the internet, on FTP and websites, and will be also available in printed copy as well for basically copying charges. So we just are looking to build this movement as rapidly as possible because the more people that are on the air, the better off everyone's going to be because the FCC will just have that many more people to go after and a limited amount of resources to do it. And I also urge you to do public forums in your community as well. Maybe you don't want to put a transmitter on the air, but consider putting on a public event and discuss with people who come, why should the corporations have almost all the communications resources in this country? Why isn't there a democratic form of communication available to the average people? These are all issues that need to be raised because it's really vitally important in order to people to effectively fight or organize in the community, they have to communicate. And if all the means of communication are held in corporate hands and the corporations are wanting to shove various agendas down the community's throat, well, there's no way you can really effectively fight against it unless you have your own voice. And this is how a community can achieve its own voice, through the technology of micropower broadcasting, through a dedicated effort of communities organizing to have that kind of voice. And that's what we're going to really leave you with, is that whole idea of what does it really mean to have democracy in this country. It's something we really haven't had, in my opinion. We've had this false presentation where convenience is equated with freedom, where there's an apparent wide spectrum of opinion, but in fact it's a very narrowly defined spectrum of opinion. If you read the analyses of Noam Chomsky and others, it becomes rather apparent what the real story is. So, in closing, I'd like to say this is something that you really should look at doing very seriously. If you go into it, realize the responsibilities you have, not only in a legal sense, but in a sense to the community itself. It is, once you put this stuff together, how do you become a voice that's reflective of the diversity of the community? I mean, from left to right and middle and all the way in between. It's a way of bringing people together from disparate views and point to communicate and share ideas and realize we have a common ground here, that we have, no matter what our viewpoints are, we have a situation where our lives are threatened by so many different entities. I mean, entities within the government, entities within the corporations. The whole planet itself is possibly threatened with a massive collapse of the whole entire biosphere if certain trends keep continuing. And this is a way that we can organize and perhaps change the direction of things as they are now in this country. That's all, folks.
I'm like others, I can find the time to be kindly by the energy. Where is the energy? I'm like others, I can find the time